So till now we have seen the details of the example program which is given as an input to the assembler. So the example program, it will be having some opcodes, labels, operands, assembler directives also will be there. So a mixture of this will be given into the assembler. So now you need to know what the assembler does. So there are some main functions. Main function was like translating into the machine equivalent and assigning addresses to the labels. So more than that, the functions can be given like 5. Like convert the mnemonic operation to their machine language equivalents, convert symbolic operands to the machine addresses. So apart from that, decide the proper instruction format. Okay, instruction formats, you know, different types of instructions are there. So which instruction format it need to follow, it decides, and converts the data constants to the internal machine representation. Some data constant will be there which will be converted to the internal machine representation. Then finally it writes an object program and assembly listing. So these are the functions of assembler that performs in the input source program. So converting symbolic operands to their equivalent machine address, it comes across two things, that is forward references and to passes. These two concepts you need to know. Forward references we can explain in the program, and to passes, it is like it will be having two passes, first pass and second pass, or it will be like pass 1 and pass 2. So in pass 1, it scans the source program for label definitions and assign addresses, and in pass 2 it performs the actual translation. In case of pass 1, it will be having some labels or symbols used in the program. Those labels will be assigned some address value in pass 1. And in pass 2, the actual translation, that is to the machine equivalent, the source program will be translated. The translation process will be done in the second pass. So this is the program that we have learned earlier. What is the difference you can notice from here? You have an additional column, that is LOC, and an additional column, that is object code. So LOC, it indicates the address values. So while explaining the program itself, I said start 1000 means the next instruction will be having this address value. So the next instruction is first STL with address. So this 1000 will be assigned for that instruction. Okay. So object code is like it will be generating an object code based on the instruction given. Okay. So how it is generated in detail you will be learning later. For time being, for understanding, you can just understand it like this. STL is an opcode. So for every opcode, there is a machine equivalent code defined for the SIC as well as SIC-XC. So when you check the textbook, towards the end of the page, towards the end of the textbook, last pages, you will be having the machine equivalent code for the different opcodes that is listed here. Okay, for different opcodes that we are using in SIC assembler, the equivalent machine code you can see towards the end of the textbook, that is mentioned in your syllabus. So in this for this STL, the equivalent opcode value is equivalent machine value, equivalent value is 14. Then writ address. Writ address, what does it mean? Writ address will be some value that is obtained or defined later in the program. It indicates some value that is assigned later in the program, but it is stored elsewhere. So that the value can be assigned to this RIT address. Here RIT address it is stored where? In 1033. 1033 only this RIT address value is stored, but it is being used earlier in the program itself. Okay, so earlier in the program itself it is used, but the address is defined elsewhere. That is, after the usage only the address is defined for this RIT address. Why? RIT address is treated as a label which is used in the program, and the purpose is to store the return address value, and it is used for returning from the subroutine that is being called. Okay, then here RIT address എന്ന് പറയുന്നത് define ചെയ്തിരിക്കുന്ന address എന്ന് പറയുന്നത് 1033. RIT address എന്ന് പറയുന്ന ഒരു symbol അത് treated as a label here, which is defined the address 103. So here the object code will be like the opcode value, machine equivalent of the opcode value, followed with operand, that is a label, and the address given to that label. Okay, so this object code will be generated by the assembler. The function what you are going to study is how this object code is being generated. How this object code is being generated. In order to generate this object code, we make use of some data structures. Say for every line of statements, an equivalent object code is being generated. So in order to generate this object code, it makes use of some procedure. Okay, so procedure is like for the pass 1, assign addresses to all the statements in the program. Save the addresses assigned to the labels for the use in pass 2. First task is like it assign addresses to all the statements in the program. Like this, assign addresses to all the statements. So these are the different statements. It will be assigning address based on the starting address that is given. That is the first thing which will be done. And then save the addresses assigned to all the labels for use in the pass 2. So it needs to be saved somewhere so that it can be used in pass 2. So for that purpose, it makes use of SymTab. So SymTab is one data structure which helps in storing the addresses of the labels that is used in the program. So in SymTab, in this line of statements, SymTab will be having first will be there. SymTab, inside SymTab, first will be stored F first, and its equivalent address 1000 also will be stored. The next label is C loop. What it has? 1003. So C loop. C loop is also a label. So C loop, it will be having what? 1003 as an address. The next END file. END it will be having the address 1050. Similar is the case with EOF, tree, 0, crypt address, length, buffer. So in this case, corresponding addresses of value will be stored in the syntax. So syntax will be one data structure. It will be treated as a table. Okay, one data structure which will be having information about the labels that is used in the program together with the address value. Okay, so this is the first task that is done during the pass one. And then perform assembler directives including those for address assignments such as byte and RESW. So hope you are remembering about the difference between byte and RESW. Byte helps in reserving the address based on the string constant that is need to be assigned. And RESW will be like it helps in reserving 3 bytes. Which means byte, if we give in this example word is 4096. So word for 4096 bytes will be allocated for this max length. So address will be incremented accordingly. So the next address after this will be adding this 4096 together with 205. What is the value you will be getting? That address, that much address will be allocated for max length. You can check with this. Okay. 205B. After allocating that much addresses, you will be getting 2061. In pass 2, what it does, it will be generating assembly instructions, which generates opcode and look up the addresses, generate data values defined by byte, word, then perform processing of assembler directives, which is not done during pass 1, then write the object program and assembly listing. So these are some of the functions that is performed in pass 2. The outcode will be generated and looks for the addresses. So in this case, first converts one of the function of one of the difficult function of assembler is converting the symbolic operands to the equivalent machine addresses. So why it is difficult? It is having forward reference and also it is of 2 passes. Forward reference can be forward reference means some label or symbol is being encountered and its address is being defined later in the program. So such cases can be resolved using this 2 pass. Okay, so first pass, some label's address will be assigned. The entire program will be scanned and you will be generating the labels and its corresponding addresses. Addresses will be allotted for every instructions. It checks the validity of the program based on the opcodes that is being used. In second pass, it performs the actual translation like opcodes. It will be opcodes, opcode equivalent, machine equivalent of the opcode also will be translated. Opcodes will be translated to the machine equivalent in second pass, and also it follows some structure like this: header record, text record, end record. So it has a structure in which header record will be having 19 columns. Each will be dedicated for H, program name, starting address of the program, length of the program. So this is one of the object code syntax, object code format, in which header record is there, header record, text record, and end record. Thank you.